Hi guys, my name is Vaishnavi. I am studying in Sri Venkateshwara College of Engineering. Subject is Theory of Computation. Topic is Undetectability, a language that is recursively enumerable. Introduction to non-detectable. Non-detectable is a concept in theoretical computer science and mathematical logic. It refers to problems for which no algorithm can provide a correct yes or no answer for all inputs. Understanding undetectability helps us recognize the limits of computation and formal system. Detectability versus non-detectability. There are two types of TMS based on halting recursive. TMS that always halt, no matter accepting or non-accepting equals detectable problems. Recursively enumerable. TMS that are guaranteed to halt only on acceptance. If non-accepting, it may or may not have, that is, could loop forever. Undetectability. Undetectable problems are those that are not recursive. What is recursively enumerable? A language is recursively enumerable if there exists a Turing machine that accepts it. If a string belongs to an RE language, the machine will eventually halt and accept it. However, if the string does not belong to language, the machine may either reject or run indefinitely. A language is recursively enumerable if some turning machine accepts it. Let L be a recursively enumerable language and M the turning machine that accepts it. For string W, if W belongs to L, then M halts in a final state. If W not belongs to L, then M halts in a non-final state or loop forever. Characteristics of recursively enumerable language. Recursively enumerable language can be recognized by a turning machine but not necessarily detected. They will include all regular and context-free language as well as some context-sensitive language. The set of recursively enumerable language is countably infinite, meaning they can be listed in some manner. Non-recursively enumerable language but not recursive. Recursively enumerable language. Recursive language. Introduction to non-recursively enumerable language. A language is non-recursively enumerable if no turning machine can accept it. This means there is no algorithm that can list all strings in the language. Non- Non-recursively enumerable language highlight the limits of what can be computed or detected algorithmically. Recursively enumerable language. A language L is recursively enumerable if there is a turning machine T accepting L. A language L is turning acceptable if there is turning machine T accepting L. Example, open flower bracket 0 to the power of n, 10 to the power of n, where n is greater than 0, close the flower bracket, is a recursively enumerable language. The halting problem. The halting problem is a classic example of an undetectable problem. It asks whether a given turning machine will halt on a particular input or run forever. Halt turning provided that no algorithm can solve the halting problem for all possible machine input base. The halting problem of turning machine. The undetectable of ATM and turning unrecognizable languages. Proof of halting problems undetectability. Turning's proofs involves a diagonalization argument leading to a coordination. If a machine could determine halting, one could construct a new machine that does the opposite. Its contradiction shows that such a halting detecting machine cannot exist. Halting problem in undetectable proofs. We modify H to construct a new TMH which becomes very much as H. The computation of h are the same as h1 except the h loops identically whenever h terminates in a accepting state, that is whenever h halts on input w and halts otherwise. Diagram. More example of non-recursively enumerable languages. The language of all Turing machine that do not halt on any input is non-recursively enumerable. Another example is the set of pairs of Turing machine and input where the machine does not halt. This example demonstrates the complexity and richness of language behind RE. The relationship between RE and non-RE languages. All detectable languages are recursively enumerable, but not all recursively enumerable languages are detectable. Non-recursive enumerable languages represent problems that are fundamentally unsolvable by any algorithm. This relationship showcases the hierarchy of computational problems and their solvability. Non-recursive enumerable languages. Lemma. The set of all TMS is countable. Proof. Each TM M can be described by finite limit string M. Can enumerate this string and give the natural bijection with N. Implication of undetectable. Undetectable has profound implication in computer science, mathematics, and logic. It indicates that some question cannot be answered no matter how much computational power is available. Recognizing undetectability helps research focus on solvable problems within computational domains. The role of reduction in undetectability. Reduction are a key technique for proving undetectability by relating problems to no undetectable ones. If problem A can be reduced to problem B and B is undetectable, then A must always be undetectable. This method allows for systematic exploration of the undetectability landscape. Recursive language versus recursively enumerable language. Recursive language are those for which a Turing machine can determine membership for all inputs. All recursive languages are also recursively enumerable, but the recursive is not true. This distinction is crucial in understanding the borders of detectability. Non-recursive enumerable language and formal system. Non-recursive enumerable languages often arise in the context of formal system and their limitation. Global's incompleteness theories illustrate that not all true statements can be proven within a formal state. This insight extends the concept of undetectability behind mere computation to logic and mathematics. Consequence of non-recursively enumerable languages. Non-recursive enumerable languages emphasize the inherent limitation of algorithmic process. This challenges the assumption that our problem can be solved with sufficient resource. This recognition reshapes our understanding of what constitutes an algorithmic solution. Recursively enumerable language. A language is called recursively enumerable if there is a Turing machine that accepts on any input within the language. Reminder, a language is called recursive if there is a Turing machine that accepts on any input within the language and rejects on any other input. The choosy hierarchy and undetectability. The choosy hierarchy classifies languages based on their generative power. Recursively enumerable languages correspond to type 0 language in this hierarchy. Understanding where undetectable language fit within this framework is essential for theoretical insight. Practical implementation of undetectability. In real world computation, undetectability affects programming language design and compiler construction. Understanding which problems are undetectable informs software development and algorithm design. It also highlights the need for heuristic and approximation in problem solving approaches. The practical implementation of the human element. People know hues nor algorithms. Identity, uniqueness, heterogeneity, intentionality, spontaneity, free will, agency, intelligence, learn, co create new knowledge, share knowledge. Limitations of automated theory proving. Automated theory proving faces challenges due to undetectability in certain logical systems. Some logical statements cannot be detected algorithmically, limiting the scope of automated proofs. This emphasizes the need for human intuition and creativity in mathematical reasoning. Research directs in undetectability. Research continues to explore the boundaries of detectable and non-detectable problems. New techniques in computational complexity and logic aim to identify more undetectable languages. The interplay between computability and complexity remains a vibrant area of student. Teaching undetectability. Educators emphasize the importance of teaching undetectability in computer science cruelly. Understanding this concept prepares students for challenges in theoretical and practical computing. It encourages critical thinking about the capability and limits of algorithms. Summary of key points. Undetectability reveals the limit of computation through the lens and non-recursively enumerable languages. The halting problem and other examples illustrate the profound implications of undetectability. Recognizing undetectable problems shapes our understanding of algorithmic and logical challenges. Conclusion and future directions. The study of undetectability is essential for advancing theoretical computer science and mathematics. Future research will continue to uncover new languages and problems that defy algorithmic solution. Understanding this concept will remain crucial as technology and computation evolve. Thank you.